Our lesson for today will be looking at chemistry 1502. The topic for today is Iupac, naming of alcohols. Lesson on O2. Let us start. The first lesson video of this lesson series of alcohols, we've looked at the introduction of alcohols. We've also looked at different types of alcohols, and we went through in detail to explain the primary, secondary, tertiary, and also the phenols and enols. So in this lesson video, we'll be looking at how to name those compounds that consist of a hydroxy group. As always, there will be steps that we need to follow in order to write the correct Iupac name of a particular compound. So far, we've looked at the Iupac naming of the first few groups which we've discussed so far. So this is one of the groups that we need to know how to name, and the rules are more or less the same with the first few groups that we've discussed so far. So our first example that we are going to apply the rules to find its Iupac name is this type of a compound, and remember that it must be an alcohol. In order for it to see that is an alcohol, we see by the hydroxy group, and we can be able to tell which type of an alcohol this is by looking at the hydroxy group, which is this one. You can see that the carbonyl carbon atom is here. It is bonded to two other carbons, which makes this a secondary alcohol. So following the rules as usual, we start by trying to allocate or trying to determine the longest chain. In this case, we can see that this will be our longest chain, and then we count how many carbons we have. We have 1, 2, 3, 4, 5, 6 carbons. Then we know very well that our parent name will consist of, or the Iupac name will consist of hex. We know that hex represents 6 carbons as our parent chain. If you can review from the first groups, let's say the alkanes, we know very well that the ending name will end with ANE. So since we're dealing with alcohols, you should know that the ending name will be OL. And then for this, it will be hexanol. But I'll explain this in detail, how to correctly write the Iupac name. So for 6 carbons as our parent chain, whereby we have the hydroxy group, making this compound to belong to the alcohols, the ending name will be OL. Then we say this is hexanol. We also have methanol, hexanol, heptanol, propanol, butanol. So this is one of the differences, or an indication that we should bear in mind to be able to tell which compound it belongs to, because sometimes you'll be given the Iupac name, and then with this it will tell you that you should include the hydroxy group. Step number 2, we have to check where do we start to count. We can either start here as carbon number 1, or we start here as carbon number 1. But remember that this is our group and it will take priority. It should have the lowest number. So if you start at this side, you have 1, 2, 3, 4, 5, 6. You can see the hydroxy group, it's on carbon number 4. If we count this side, we have 1, 2, 3, 4, 5, 6. So you can see that if you start from the right hand side, this our hydroxy group will be on carbon number 3. So we have 3 as our hydroxy, the position of the hydroxy group, and this 3 When in lower levels of chemistry, we put 3 hyphen. This 3 represents the position of the hydroxy group. Then this represents the parent chain, whereby the ending name is OL. Or we can write it like this, which is a way that I want us to use. We're going to say hexan, we put hyphen, 3, and then or. These two, they mean the very same thing, but I want us to stick to this. So we can just remove this one. So the next step that we need to do now, we have to check the substituent, the branches. So since we have discovered, or we have determined where do we start from the right, and then we check. This is the substituent that we have, which is a methyl. Then if you can check methyl, it's on carbon number 5, so we have 5 methyl. And then after this, we can combine our names because we don't have any other substituent. Let me quickly rectify this. It's 5 methyl. And then from here, let us go ahead and combine our names. So we have 5 hyphen. Remember that between numbers and weights, there should be hyphen. Between numbers and numbers, there should be a comma. So it's 5 methyl hexan 3 ol. And here we don't have a space, it's actually one weight. So this is the name of this particular alcohol. And then this is example number 1. Let us go to example number 2. What I normally do, I normally start with the easiest, so that when I display these examples, you can be able to move with the lesson video, meaning that you can pause, try to work it out, and play the video. So the next one, let us do this one. Actually put another CH2 here and then OH. So you can go ahead and pause the video, work it out, and play the video to verify. So in this case, how many carbons do we have? The parent chain, it's actually this one, and the parent chain will always consist of a hydroxy group attached to that particular chain. So we have 4 carbons. Then you can see that this will definitely be carbon number 1, 2, 3, 4. So we have butan, then we put hyphen carbon number 1, or we can just say butanol. Remember that if it is on the first position, we can drop this number, so anyway it's actually correct. Then we don't have any substituent, so this will basically be the Iupac name. Let us look at this particular question. By the way, this is example number 3. Now in this one we have work to do, because if you can check, we have our hydroxy group, which is good. It simply means that this belongs to alcohols. And then we have an halide here, or alcohol, I mean halogen. And then we have a methyl here. So looking at the parent chain, so that we can take this route, or we cannot take this route. It is the shortest, it's actually not the longest. Or we can take this route, or we can basically take this route. So in this case, if we start counting this side, we have 1, 2, 3, 4, 5, 6, 7. So we have 7 carbons as our parent chain. If you count this side, we have 1, 2, 3, 4, 5, 6, 7. Now if you can check, if you start from left to right, go in this direction, you can see that chlorine will have, it's actually chloride once it is bonded. So chloride, you can see that it will have a smallest number, but it is the same when we take it this direction. But comparing it with a hydroxy group, you can see that chlorine will have 4, and then hydroxy group will have 6. And then when you take it this direction, hydroxy group will have 2, and then chlorine will have 4. So which one is correct? In this case, you should know that our priority will be the hydroxy group. So it means that we cannot take it this direction. Hydroxy group cannot have a bigger number compared to our chloride, because you can see that if you take it this direction, chloride will have 4, and then hydroxy group will have 6. So you're going to start counting from left to right. Then we have seen that the parent chain is heptanol, and then the hydroxy group it's on carbon number 2. So we have hepta 2 or it's heptanol. Then let us check. If we start from left to right, we can see that our chloride is on carbon number 4. So we have 4 hyphen chloro. Then when we count from left to right, we can see that our methyl is on carbon number 6. So our last part is 6 methyl. And then we have to combine these names, but remember that we need to follow alphabetical order. So we look at C and M, definitely sure C will come first. So we have 4 hyphen chloro hyphen 6 hyphen methyl. Then it's one with hepta 2 all. So this is the Iupac name for this particular compound. You should not be afraid of cyclics. We are going to be seeing more of them, and they are pretty much simple, interesting. So what is the Iupac name of this one? We have to count the ring. You can see that the ring, remember that each and every corner represents carbon. So in this case we have 6 corners, which is 6 carbons. Then the question would be, which one will take the preference? Are we going to start here as 1, or are we going to start here as 1? Now between hydroxy group and methyl, we take the hydroxy group as our preference. So we have 1, 2, 3, 4, 5, 6. And then you should know that the cyclics, we indicate or we name them as cyclo. So the parent chain will involve or will have this with cyclo. So since we have 6 carbons in a ring, so it's cyclo hexan. Then we look at the position. As you can see, it's position number 1, so it is safe for us to not actually write it. So we have hexa cyclohexanol, and then in carbon number 2 we have our methyl. Then we just have to combine this. So we have 2 hyphen methyl cyclohexanol. Sometimes we do have those alcohols or those compounds which they have more than one hydroxy group. We call them dialcohols. Sometimes you might hear diols, and you should know that we call this glycols. The name for these types of alcohols, we call them glycols. So let us look at how to name the glycols. Suppose we have this particular compound. Now you can see that this type of a compound is actually symmetric. So even if you start this side, you say 1, 2, it's the same as 1, 2. The first carbon has the hydroxy group, and when you start from the right, the first carbon also has the hydroxy group. So it doesn't matter where we start. Then we can see the parent chain. We have 2 carbons, which is F. The moment we have 2 hydroxy groups, you should know that we are going to also indicate that these are saturated alcohols. What do I mean by saying saturated alcohols? There is no double bond between carbon and carbon. We don't have any double bond between carbon and carbon. So it simply means that we have a saturated alcohol. Should it happen, maybe we have a double bond here, we would say this is an unsaturated carbon. Since it is a saturated carbon, you should know that the parent name will have A and E. This only happens when we have 2 hydroxy groups. So the name will be ethane, then we have hyphen. We have to indicate where we find those hydroxy groups. We find it from alcohol number 1 and alcohol number 2. Then we put hyphen, it's diols. So this is the name. Sometimes you might find it written like 1.2, it's 1,2 hyphen ethane diol. Let me actually rectify this. It's not diols, it's a diol. Another name for this is ethylene glycol. So that's it for this lesson video. We were looking at the basics of Iupac naming of alcohols. The next lesson video we'll be looking at more complex questions or compounds. This is Paula SJ. Thank you very much.